All right, this is a quick video on the RF demo kit for the NANOVNA, which I received in the mail from AliExpress just yesterday, but the NANOVNA has not arrived yet. So I thought I'd run a test of this section of this demo kit, which is an attenuator, which attenuates at 6.5 megahertz, the center frequency, using my Digilent Electronics Explorer board and waveform software. That software has a network vector analyzer built in, which some very powerful features, so we thought we'd take a look at that. I was looking at the component here that's used for the attenuation, this blue component. I've got the data sheet here. I wanted to know what they're using. It's called the ceramic trap filter, and it's this model on the bottom, the XT6.5MB, which has a center frequency of 6.5 megahertz and a minimum attenuation of 35 dB. So we're going to run that through the test. The input on this section of the board here is on the left and the output's on the right. And I'll show you the wiring here. So here's that demo kit. Here's the section of the board. We've got the cables connected, input on the left, output on the right. The cables actually come with this board, and they're connected into channel 1 and channel 2 of the scope on the Electronics Explorer board. And then we feed the waveform generators channel 1 into the input of the scope channel 1, which also feeds into the input of the device. And then the output feeds back into channel 2 of the scope. So the software can look at the difference between the input and the output on the scope and plot the results. So back over here to look at that. Bring up the waveform software. So here it is. It's pretty cool thing. It's got the ability to set your start and stop frequencies, the number of steps as you sweep through the frequencies, the amplitude. It's got a little map showing you how you hook the thing up. Here's your attenuation plot, dB on the left, and then here's a phase plot. As you can see, I've already run this. You can also plot some other things over here. This is called a Nyquist plot. I don't really understand what that is. I'll have to learn about that. But let's run this through its paces. So I'll just hit single and we'll sweep through here. So here we go. And that's indeed very much representative of the curve on that demo board. And here I have the ability to come over and take a look. Here we are at 6.5 megahertz, which is the center frequency. The input is at minus 2.7 or 2.8 dB, and then the output is as low as 45, 46 dB. So we're getting more than say 43, 42 dB of attenuation, which is better than the spec says. And then here's the phase shift as it goes through. It sweeps through those frequencies. Here's the Nyquist chart. The other thing you can do is look at this over time, which is kind of interesting. Let's bring that up. And the yellow is the input signal, and the blue is the output. And then as you run it, you will see the yellow constant, and then the blue sweeps down and goes to zero. Is actually attenuated and then back up. So there's a bunch of things here. Why they don't have a Smith plot, a Smith chart, I don't know. I'm going to actually ask the folks at Digilent and see if they can explain that, or whether they were maybe working on it and going to add it to the software in the future. So that's it. That was a quick video showing a demonstration of this RF demo kit and the Digilent software and hardware. Thanks for watching.